Hi, series circuits. The components in series circuits are arranged one after another, and the current flows through each component in turn. Therefore, the current in a series circuit is the same everywhere. The current is not used up, but the energy carried by the current is. So, remember, I am a coulomb of charge. This sweet is a joule of energy. 1 sweet in my hand represents 1 joule of energy for every coulomb of charge represents 1 volt of voltage. So going through this cell, each coulomb of charge gets 2 volts, or 2 sweets per student. Now, as the current comes round, there's one opportunity, because there's only one component, there's one opportunity to eat sweets. Here, you've got 2 sweets again for every coulomb, but you've got 2 opportunities to eat the sweets. So here you have to eat both sweets at once, and here you get to eat 1 sweet and then go on and eat another one later. The energy carried by the current is the voltage. Voltage is shared by components in series. Let us suppose our bulbs have a resistance of 10 ohms, symbol ohm. Now, the resistance of this circuit is 10 ohms because there's a 10 ohm resistance, which is this bulb. Here we've got one 10 ohm resistance bulb and another 10 ohm resistance bulb, so that's 10 ohms plus 10 ohms equals 20 ohms. Now, we can use Ohm's law, V equals IR, to calculate the current in these 2 circuits. We rearrange V equals IR by dividing both sides by resistance, so we get V over R equals IR over R, the R's cancel, and we get current, which is what we want. Now, in the first circuit, the current is 2 volts divided by 10 ohms, so that's 0.2 amps, which means it will take 5 seconds for a coulomb of charge to go past. Here in the second circuit, we have 2 volts, and there are 1 bulb, 2 bulbs, each of 10 ohms, so we're getting 20 ohms altogether. So 2 volts divided by 20 ohms equals 0.1 amps. So it's now going to take 10 seconds for a coulomb of charge to go past. Adding components in series increases the resistance, and so reduces the current in the circuit. We've added another component in series, we've increased the resistance of the circuit, so we've reduced the current in the circuit. In the first circuit, there is only one component, so it gets the complete 2 volts supplied by the cell, okay? In the first circuit, there is only one component, so it gets the complete 2 volts supplied by the cell. In the second circuit, there are 2 components in series, so they will share the voltage. As the 2 bulbs have the same resistance, they get half the voltage each. Voltage is shared by components in series in proportion to their resistance. Thank you very much.